Welcome to the Vojo Health podcast. I am here with Ahmed El-Sohemy. As a quick introduction, you're a professor in Nutrigenomics at the University of Toronto, where you've been for over 20 years, and the founder of Nutrigenomics, which is with an X, a genetic testing company for nutritional professionals. Today, we're going to be talking about genes associated with iron absorption and how they relate to premenstrual symptoms, sport performance, and lots of other things. Iron is, of course, a very important nutrient and more difficult to get from a plant-based diet compared to meat, which is why we talk a lot about it at Vojo. At Vojo, as I'm sure you do at Nutrigenomics, we analyse all the iron-related genes you include in your papers, so it would be great to discuss them all and their effects. So just to provide some context to our listeners, firstly, would you like to introduce more about yourself and how you got into nutrition and genetics in the first place?
Sure. First of all, hi, Ellie, and thank you for inviting me on your show. Yeah, as you said, I'm a professor at the University of Toronto, where I've been doing research in the field of nutrigenomics and nutrigenetics for just over 20 years now. Our research has focused over the years on a variety of different outcomes, things like cardiometabolic disease, but also areas that have been under-researched, like premenstrual symptoms, and also athletic performance. So really our research, kind of runs the gamut of all kinds of different outcomes that we find of particular interest and obviously have relevance and importance and significance to different populations and different individuals.
Iron is a very interesting nutrient, isn't it? Because we hear a lot about iron deficiencies, and obviously you need to have enough to be able to do important things like build red blood cells and everything else. But you also shouldn't have too much, because high iron levels are also associated with cardiometabolic diseases, diabetes, things like that. So it's really important to get the right balance.
Yes, you're right. And it is one of those nutrients, like I suppose every nutrient, but in particular, because of the well-known adverse effects of too much iron and potentially toxic effects in some people who have a specific genetic predisposition to absorbing too much iron. But as you say, it is one of the most common micronutrient deficiencies in the world. So clearly it's important to ensure that people are getting adequate amounts without getting too much, where you run the risk of experiencing some of the harmful effects of too much iron.
So a good place to start would be how your genes can affect your iron levels. So very simply, how does that work?
Sure. Well, it's been known for quite some time that this inherited condition called hemochromatosis, or also called iron overload, can occur. And this is where individuals have a particular version of a gene that results in too much iron being absorbed from the gut. And what happens, of course, is that iron builds up in various tissues, such as the liver and joints, and causes tissue damage and can ultimately cause organ failure. And so since then, that gene called HFE has been identified, and specific polymorphisms or variations in that gene have been shown to predict the risk of having iron overload. And so those are the genetic markers that, as you mentioned, are covered in your panel, and also what we test at Nutrigenomics. We've also found out over the years that there are also genetic markers that can explain, kind of the other side of the coin. Not too much iron, but not enough iron being absorbed. So some individuals have variations in these other genes that impair their ability to absorb iron and to utilize iron. So again, when we're looking at the genetics, it's really a balance of looking at those who have the risk of not getting enough iron absorbed versus those who have the risk of absorbing too much. And so we had, created an algorithm, of course, that tries to balance that, because there are some people that have both of those genetic variants. And so the question is, what do you do with them? Well, we know that really the iron overload, kind of piece of the puzzle really supersedes what happens from the other end. So it's most critical to ensure that someone does not have too much iron, because some of those harmful effects can be irreversible. And so our recommendations are really kind of based on the balance of the combination of the different genes that individuals have. And so to try to understand that more, because these genes have only been recently discovered, we have been conducting some of original research of our own to try to understand how these different combinations of genes impact various outcomes of interest.
I was really excited to see your papers, especially the one on how these iron genes affects premenstrual symptoms, because this is research that I haven't seen anywhere else. And as you say, most of it focuses on cardiometabolic diseases. So the fact you're focusing on things like PMS and sport performance, which is really relatable to a lot of people, is it's incredibly useful. Why do you think there haven't been more studies in these areas up to now?
It's a great question, and particularly when it comes to premenstrual symptoms. And as I mentioned earlier, I think it's been surprisingly a neglected field of research, because the fact is, not everyone experiences those symptoms, and some women experience it much more severely than others. And because it's not officially classified as a disease, premenstrual dysphoric disorder, which is an extreme and rare form of PMS, is classified in the DSM, which is the kind of official manual of mental health conditions, or psychiatric conditions, I should say. So it is recognized as a condition, but regarded as something that's primarily due to hormonal imbalances or differences in response to hormones. So not that the hormone levels are different, but the women respond differently to those fluctuations during the menstrual cycle. So again, unlike cardiovascular disease and cancer, where researchers can document the number of deaths attributed to that and the impact on healthcare systems, and they can get grants to fund the research. It's much less likely to happen with something like premenstrual symptoms. But when you think about it, it really can be extremely disruptive to the quality of life of a lot of women. And that's why when we established our Toronto Nutrigenomics and Health study at our team meeting, we were brainstorming in terms of, what else can we set up our study to examine. And this came up as one of the topics. And again, some of the women in the room responded by saying, oh, well, I actually don't really experience it that much. Others are like, you know what, I'm completely incapacitated for 2 or 3 days of the month. So we thought, okay, not that was great, but it's fascinating from a research perspective to see that people can respond so differently to a particular stage of their life cycle. So we thought, okay, well, let's look at what research has been done. What are the validated questionnaires? What are those symptoms that some women experience while others don't? And let's start examining that in our cohort. And so that's what we did. We were building up our database, and so we recruited just over 1,600 participants. And we've been looking at other aspects of premenstrual symptoms. We published a paper a couple of years ago showing that low blood levels of vitamin D can contribute to certain premenstrual symptoms, but not others. And so this more recent research that we've conducted has been focusing on iron.
So what exactly did you test and what did you find?
So for this latest work, we wanted to investigate the role of iron because there has been some indirect evidence to suggest that it might contribute to premenstrual symptoms. Part of that evidence is things like, estrogen, which is known to impact premenstrual symptoms, alters iron metabolism. Iron is required for the synthesis of some neurotransmitters like serotonin, which we know can affect things like mood. And so based on that kind of circumstantial evidence, we sought to explore whether or not iron is linked to premenstrual symptoms. Now, the approach we took is one that's called Mendelian randomization. And that's just a fancy word that geneticists use to describe looking at a gene that is indicative or predictive of iron exposure. So rather than looking at a dietary questionnaire, which we know have, they're not perfect in terms of determining how much iron a person is actually consuming, we used variations in genes that predict blood levels or blood stores of iron, because these genes, almost regardless of how much you're consuming, are pretty strong predictors of how much of that iron your body actually utilizes. And so based on that study design, we found that those who have a particular version of a gene that results in higher iron stores, those women had a lower risk or likelihood of experiencing certain premenstrual symptoms.
And this was the HFE gene?
Correct. And that's the one that predicts iron overload. Now, I should mention that this HFE gene that does cause iron overload and hemochromatosis and some of these adverse effects, obviously it's less harmful to women, because women, based on their menstrual cycle, do lose blood, every month, and so that decreases the likelihood of having that, the overload of iron. Whereas men who have this version of the gene, they are at a higher risk of the adverse effects of iron overload, because they don't have that kind of monthly clearance of iron from their system.
So you might have this gene and you may not have full-blown hemochromatosis. So you may not have any sort of diagnosis or even experience any of those negative side effects associated with iron overload, but you could be experiencing something like, you could be experiencing other more subtle effects of having that gene. Is that correct?
And again, because in our study on premenstrual symptoms, obviously we were only investigating this in women, so many of them probably might not know that they have this, because if anything, it's protecting them from iron deficiency anemia, which is actually much more common among women. So they might actually have, pretty normal or the upper end of normal when it comes to their iron stores, because they have that kind of the monthly clearance. But at the same time, during the rest of the cycle, they are absorbing more iron. And so a more prevalent situation is really iron deficiency anemia among women in that age category that are menstruating.
So it could actually be a good thing to have this gene for some women.
Absolutely. But again, it really is kind of a balance. And also it
Yeah.
takes into it, one also has to take into account dietary intake because typically women of in that age category of, early teens to premenopause are sometimes advised to take an iron supplement because they're not always able to get sufficient amounts of iron in their diet, and because of the loss of blood each month, then they're at a higher risk of deficiency. But if they have this version of the gene, that might actually protect them from deficiency.
And if they have that gene, what effect would taking an iron supplement have or could have?
Well, then it could, depending, of course, on how much iron is in the supplement, but it could have adverse effects because then you will be storing, first of all, absorbing too much iron, and then storing it, and then that would lead to some of that tissue damage that I mentioned. But yeah, it really depends on the amount, because even for those who do have hemochromatosis, the recommended intake of iron is the RDA, the recommended dietary allowance, which is similar to someone who does not have this gene. They just need to be mindful of not consuming more than that because of the adverse effects they would experience.
Yeah, a lot of supplements for vegans and people on plant-based diets contain iron because obviously a plant-based diet has less iron or less absorbable iron than a meat-based diet. So is that something that people on a plant-based diet should be wary of?
Well, I'm glad you mentioned, specifically perhaps less absorbable, because of course we know that, many legumes are actually quite rich in iron.
Yeah.
And it's interesting because, my background is Egyptian, and when I think of some of the staple foods that are consumed there, like for breakfast, there'll be a lot of, chickpeas and fava beans, and it's interesting because I know that something like fava beans, the dish is often prepared with lemon. And so when you think of, I don't know why that is. Maybe, once upon a time someone discovered that, they're healthier if they put lemon in their fava beans. But fava beans are quite rich in iron. But of course, knowing that it's non-heme iron, but vitamin C clearly can improve the absorption of iron. So just the way that it's something that kind of popped into mind a few months ago as I was preparing a dish of fava beans and putting lemon on it, and I realized, hey, this is actually helping to absorb more of the iron from the bean. So. Sorry, it's a bit of a tangent, but it just kind of popped to mind because I just realized that, when we're looking at heme versus non-heme, obviously you want to consume it with a good dose of vitamin C to enhance the absorption.
No, yeah, it's definitely a good tangent to take. I'm happy with that. Yeah, I've been thinking the same actually. Like a lot of more traditional dishes do combine high iron plant foods such as beans with something citrusy or high in vitamin C, like hummus as well. Like that's chickpeas and lemon juice. And there are lots of examples. So I think there must be something there. There must have been at some point people realized that okay, this is a good combination for health somehow. It's very interesting.
Yep, absolutely. I mean, I myself have been. I mean, I'm not vegan, but I've certainly been, incorporating much more kind of plant-based foods in my diet, and doing that, of course, I'm also, mindful of what I might be at risk of deficiency for. So things like, B12, iron, and again, that's when it kind of popped to mind that, hey, just based on how dishes are prepared, you can actually optimize or maximize the absorption and utilization of some of these nutrients.
Good to hear that you're incorporating more plants into your diet, by the way. We'll get you 100% eventually, but
Getting
don't
there,
tell
slowly,
anyone.
baby steps.
So your study on premenstrual symptoms, you found that people with the higher absorption genes actually experienced a lower rate of premenstrual symptoms.
Correct.
So this might explain why I have never experienced premenstrual symptoms. I'm only heterozygous for the HFE gene, the main one. So that's, I always like to say, half a gene. It's like there are two alleles per gene, and I have one of them. And I've never experienced premenstrual symptoms in my life, and it always shocked me how much other women experience. Like a long time ago, I used to say, people are just making a big fuss over nothing. But actually, of course, there is such a difference in experience. And
Absolutely.
yeah,
In fact, it's funny
now
you
I
mention
can
that.
understand.
Yeah. I mean, it's funny
Go
you
on.
mention that because I know, some of the women that I've known who have it in a very bad way, they actually say that sometimes it's, other women who are, just kind of less sympathetic because they experience something very different. And to them, it's like, oh, yeah, sure, I'm bleeding, but, I go into work and it's fine. Whereas they are absolutely incapacitated, crippling cramps. Again, when you think of the more severe form of it called PMDD, or premenstrual dysphoric disorder, it gets very bad, both physical in terms of excruciating pain, but also the psychological that even leads some women to commit suicide. So it is absolutely a very important health condition that we do need to take seriously, and we need to uncover some of the risk factors and see what we can do to help these women cope beyond extreme measures like some surgical procedures and certain kinds of hormonal treatments that have other adverse effects. So if there's anything we can do in terms of diet and lifestyle to try to alleviate the severity of some of those symptoms, I think that's a good step.
This is what I love about genetics. There are two sides to it. There's the part where you can actually understand and empathize with other people because they don't experience the same thing as you. And now you can see why. Okay, they are genetically different to you. This is why their experience is different. And on the other side, it's actually coming up with actionable things that people can do, which are personalized to them, which are more likely to work for them. So, it's an all-round good thing to be able to personalize these things. With PMS, what can people do if they have if they don't have the iron absorption genes, for example?
Mm-hmm. Well, I think what at least this initial study has shown is optimizing, or at least it suggests that kind of upping your iron stores might alleviate some of these symptoms. So perhaps someone who is experiencing some of these symptoms may want to have their blood iron levels measured through their physician. And if it's not near the upper end, then perhaps they can discuss with their healthcare practitioner a certain supplementation regimen that could up their iron stores, kind of towards the upper end of normal, as opposed to average or even, lower end. And the same thing goes with a lot of other micronutrients. There's been some research on calcium. It's probably one of the more widely studied micronutrients on premenstrual symptoms. Again, not that there's been a lot of research. Also some evidence on vitamin B6. But again, we hesitate to recommend just, multivitamin for everyone every day. But it's really trying to understand which of the particular micronutrients a person might have insufficient levels of. And that's determined, as you know, not only by their diet, but also by their genetics. And that's why it's important, and it's great that you offer that kind of service where you help individuals understand which micronutrients they need to focus more on because of how their body processes that. Do they absorb or utilize too much of it? Things like sodium, for example, and they need to really kind of cut back. Or are they less efficient at utilizing it? Something like B12 or vitamin D, and they need to kind of up their intake or focus a little bit more on that particular micronutrient. So it is all about kind of being personalized, but as you say, understanding those outliers, those exceptions to the rule, help us better understand what we can do for kind of the general population.
Yeah, I love how you say it's about helping people understand themselves and how their diet and nutrition and what they can do for them. That's always such a big part of my work, and I'm sure yours as well, is to help people really understand themselves and do what's best for them. But of course, it's never just about one nutrient, right? Or one gene. Like, everything interacts with each other. We've already mentioned vitamin C, and you just mentioned calcium as well. So calcium can actually inhibit the absorption of iron, whereas vitamin C can increase it. So, it's not just about iron in this case. It's about several different nutrients as well and how they interact.
Yeah, absolutely.
So you also studied the effect of these genes on sport performance. What did you find there?
Right. So we actually had a couple of students working simultaneously on these two different projects, but looking at the same genes. And interestingly, we published these two papers, I think, within the span of 1 week apart. So the second paper that you mentioned, we found that among athletes who have the version of this HFE gene that increases the risk of iron overload or too much iron, they actually perform better in an endurance trial. So we conducted this 10-kilometer cycling time trial. So athletes got on a bike and they were told to cycle as fast as they can for 10 kilometers. And then we looked at how much time it took for them to complete it. And those who had the version of the HFE gene that results in more iron being absorbed, which again, as you mentioned, has a risk of toxicity, but because they're increasing their iron stores and their oxygen utilization, they actually performed better. They cycled quicker. It took them less time to complete 10 kilometers. We also found that those same individuals had a higher VO2 max, and so that's a term that's used to describe oxygen carrying capacity. And again, it seems to make sense because we know that if you don't have enough iron, you're not going to your muscles are going to be starved of oxygen, or at least they're not going to get as much. So when you think of hemoglobin as a major carrier of iron and oxygen in the circulation, and myoglobin, which serves a similar role in muscles, you really need to have optimal iron stores to ensure that you're performing, that your muscles are not being limited in terms of what they can do. And so, yeah, we thought that was quite interesting.
I love how this is a great example of how there's there's always a positive and a negative side to all genetic variants. And a lot of the time, as we began with, we hear about the negative side of having this HFE gene, which is hemochromatosis and iron overload and all of these bad things. But you're studying all of these, you're finding all of these good things associated with having these genetic variants. So it's a lot about knowing what genes you have and how to manage them and how to work with them and how you can get the best out of yourself by knowing this information.
Absolutely.
So I'm very grateful for the studies that you're doing in this area.
Thank you. I mean, again, as you say, we often, a lot of these genes or versions of a gene that we consider harmful, they exist because clearly at some stage there is some evolutionary advantage to having them. We think of certain genes. The name just slips my mind. That's common in certain African populations. I think it's a G6PD deficiency. It slips my mind the name of the gene, but individuals who have that, so even though it predisposes to certain adverse health conditions, they're actually resistant to malaria. And malaria is quite common in certain African nations. So whereas you might think that it's a deleterious genetic condition, it actually sickle cell. That's the one I was thinking of. So the gene that causes sickle cell anemia, obviously adverse effects, but they are protected from malaria, which is common in those parts of the world. So again, it's we're not saying HFE is necessarily a good thing all around, but also it's not a bad thing all around. It really depends on the circumstances and the conditions, and for individuals. And this is really why I'm so passionate about personalized nutrition. It's to help people understand how to work with the genetic cards that they've been dealt. We don't like to think of a bad version of a gene versus a good version. It's this version, what can we do with that versus a different version?
Exactly. And yeah, like you say, every gene or every polymorphism is there for a reason, and it was valid at some point. Maybe not now for you in this environment, but there are things you can do with it. Correct me if I'm wrong, but HFE came about originally because in certain areas there was poor iron content in the soil. And so having the HFE gene helped you absorb more iron, obviously, from your food when in areas where there wasn't so much available. So yeah, it happened for a very good reason, to help with human survival.
Absolutely, and there's a lot of those kinds of examples. It's thought that the gene for lactose intolerance, or actually lactose tolerance, that seems to be the version that had evolved in certain nomadic tribes that were raising cattle, and those who had that version that prevented them from experiencing those adverse effects when consuming cow's milk, they were able to thrive because they had access to a very nutrient-rich source of food. Again, we see a few of those kinds of examples with different genes in different parts of the world.
Yeah, I always say that actually, if you have the gene for lactose intolerance, that's the more normal gene, or that's the original one. Which is interesting because usually it's thought of as the less normal thing to be lactose intolerant as an adult. But it's a very good argument for veganism that I probably use too much. So your research has been incredibly interesting. Where can people find out more about the research you do and the work you do at Nutrigenomics?
Well, so the research that I do and my team at the University of Toronto, I mean, we publish in various journals. I'm also the editor-in-chief of a journal called Genes and Nutrition, as well as the specialty chief editor of the Nutrigenomics section of a journal called Frontiers in Nutrition. I'm also guest editor of a special issue of Precision Nutrition, together with Professor Lynn Ferguson from the University of Auckland in New Zealand, and that's in the journal Nutrients. I'm also a guest editor, co-guest editor of a special issue on, again, personalized and precision nutrition for the Journal of Nutritional Biochemistry. So a lot of these traditional nutrition journals are commissioning or have commissioned a special issue on nutrigenomics or precision nutrition, because they realize that it's such a critical part of any aspect of nutrition. I mean, the way I view nutrition research is we now have to go back and look at everything we ever thought we knew about nutrition and health and disease, and revisit that and look to see, who's a responder and who's a non-responder. Traditionally, we've always just compared group averages, those in the intervention group versus those in the control group. And we often see a spread. You get this big standard deviation, but if there's a statistically significant difference between those group averages, we conclude that yes, this intervention is good or it's beneficial. But if you look at each individual person and how they respond, that average in that intervention group reflects some people who were super responders versus some who didn't respond at all. In fact, some might have responded in the opposite direction, but we just compare averages. So we really need to change the way that we conduct nutrition research and how we look at our data, and really focus on that variation and look at how we can better predict individual responses, right? None of us are the average person. We want to know what works for us as an individual. I don't really care what happens on kind of a typical case if there's a way for me to know how I respond individually. So through the company, Nutrigenomics with an X, we have been supporting some original research at a number of universities around the world. There was a big study that was published just last year in the British Medical Journal, Nutrition, Prevention and Health, showing that those who receive DNA-based dietary advice, and it happened to be the Nutrigenomics test, that they actually improve compliance to the recommendations, and they had more favorable changes in body weight and body composition after 3 months and 6 months. And so we had no influence on the interpretation of those results, so we just kind of support research independently, because we believe in the science and we want to continue to promote the science. Not all nutrition researchers have embraced this because they're used to their own way of doing things, and they're fine with just comparing averages. But I think if we fast forward 10 years from now, I think one would be hard pressed to find any study that gets published in the field of nutrition that does not account for or acknowledge the variation in response that we're seeing. So again, it requires that kind of ongoing training of the next generation of researchers. So a number of my former graduate students are now professors themselves at various universities, and this is how they were trained. So they only know nutrition research in the context of nutrition and genetics and individual differences in response. So as they train the next generation of students and healthcare professionals, that's the message that they're communicating. And again, over time, I think we'll see that we'll overall improve our knowledge and understanding of nutrition through incorporating genetics.
I'm so glad you're pushing this change in the way we do research, because the main problem that I hear people have with nutrition is that there's so much contradictory advice. One study says this, like one day it's this, like coffee is good for you, and next day coffee is bad for you. And it's like, these studies haven't taken into account the individual responses, the genetic responses to caffeine, for example. And that's why the research is so different every time. So it's really confusing for people. And I see it a lot with Vojo customers, that when they have their results, they finally understand. They're like, oh, okay, this is what I respond to, and this is the advice for me. And you don't have to think about or look at anything else or all the general studies, because everything then suddenly makes sense and fall into place. So yeah, thank you so much for the work that you do, and thank you so much for joining me today as well. I'm sure I'll be contacting you about a new paper that you publish in the near future.
Sure, it was absolutely my pleasure, and I'm glad you mentioned the caffeine as an example, because as you know, that's work that came from my lab, and that was a paper that we published 15 years ago now. So it seems like
Wow.
ages ago, but just about every single genetic test on the market has that particular marker, because again, we published the very first finding of that in JAMA, Journal of the American Medical Association, and it had since been replicated by other researchers looking at not only heart disease but hypertension, prediabetes, all showing the same thing, that coffee is either good for you or bad for you depending on this specific version of the gene. So again, we need to have those clear, solid examples that are replicated, and it will ultimately help clarify those apparent inconsistencies in studies that are done in different populations with different genetics. You really have to start looking at the individual, as you say. So,
considering you mentioned you're not a morning person earlier, I think you've done incredibly well. So thank you for joining us an early hour on your side.
All right, it's been my pleasure. Thank you.